Okay, ladies and gentlemen, let's talk about a bit more advanced testing. Next thing we're going to do is goodness of fit. Now, goodness of fit would be something like as follows. Company believes distribution of customers arriving during the week as follows. So what I need to do is I need to put this information in. 10 customers on Monday, 10 on Tuesday, 15 on Wednesday, 15 on Thursday, 20 on Thursday, and 30 on Friday. Now, obviously, I don't need to put in all of that information, the total information. So I have, good data here. Now, they also suggest that during the week it's randomly chosen, they would expect 31 on the Monday. They would expect 18 on Tuesday, 36 on Wednesday, 23 on Thursday, 47 on Friday, and 60 on Saturday. Now, I have a small issue. These are percentages here that are expectation. So I need to change that 0.1, 0.1, 0.15, 0.15, 0.20, 0.30. So this is my expected value, my expected percentage. These are how many people actually walked in the door. Stat, I'm going to go tables because I literally put in a table of data. In this case, I want a chi-squared goodness of fit. How well does what I see match what I expected? Remember, HO and H1. HO is always observed equals expected. H1 is that observed does not equal expected. Now, in this case, we have our observed counts, which is in C2. We have our equal proportions. Well, they're not expecting the same percentage every day, so that's not equal proportions. It is specific proportions, and those are listed in C1. Again, I don't have any options because it either is equal or it's not equal. And if I take a look here, we say, well, wait a minute, they actually look pretty good. But the way to tell is, of course, p-value. The p-value is 0.129. 0.129 is well bigger than 0.05, so we would say we must retain. We fail to reject HO, giving no evidence to support the alternative. So we fail to reject that observed equals expected, so we keep it. Observed must equal expected pretty well. We can't say that it's different. Now, that's if you have some sort of expectation. If I go down here, it says, do fatal car crashes occur with the same frequency every day of the week? So here we go. On a Sunday, they have 30 car crashes, 20 fatalities, 20 fatalities, 22 fatalities, 22 fatalities, 29 fatalities, 36 fatalities. I think that covers everybody. Yes, it does. And the question is, do they occur with equal frequency? So I'm going to go up here to stat, tables, goodness of fit. And my observed counts are now in C4, but now it's equal proportions. You notice since it's equal, I don't need to figure out what it's going to match up with. So the question is, do they happen at the same rate all the time? Well, let's find out. Maybe. Doesn't think so, but we'll see. The answer is we fail to reject HO. Observed does indeed equal expected because 0.161 is well bigger than 0.05. So we've done goodness of fit one way with two different sets of data. Now, that's goodness of fit. Let's go ahead and pick up a chi-squared test for independence. In this case, we're going to be looking for, and let's go down here. Is there an advantage in a particular sport to being home or away? Well, for baseball, we have 127 wins versus 71. We have 53 wins versus 47. Here we have 50 wins versus 43. Here we have 57 wins versus 42. So the question is baseball, basketball, baseball, hockey, and football, home team wins versus visiting team wins. Does the row have anything to do, any relationship to the column? Well, in this case, we're going to go stat. We're going to go tables. But in this case, it's no longer one variable one way. We're looking for an association. So chi-squared test for association. Now, we have summarized data in a two-way table. So which columns am I interested in? Well, C6, C7, C8, C9. Those are where my interests are. And again, HO assumes no relationship. HO says there's no relationship. H1 says there is a relationship. Let's figure it out. Well, p-value of 0.191 means we fail to reject that there is no relationship. It does not seem to matter which sport it is, whether the visitors or the home team wins. So we fail to reject HO, meaning there is no relationship. Okay, and we could do the same thing with police, cashiers, taxi drivers, and guards versus homicide or other cause of death. And again, we would be looking at stat two-way test for association. Either they are associated or they are not associated. Now, the final type that we need to start taking a look at is ANOVA. ANOVA is a little bit different. It's analysis of variance. What we're asking ourselves is the average for car 1, car 2, car 3, car 4, or store 1, store 2, store 3, store 4, are those averages all the same as mu1 equal to mu2 equal to mu3 equal to mu4? That's HO. Or H1 says is at least one different. Well, let's go with the store data. 36, 48, 32, 28, 31, 55. Over here we come up with 35, 20, 31, 22, 19, 42, 29, and 26, 20, 38, 32, 37, 15, 21. Now, in the interest of time, I'm only going to do 3 stores, not 4 stores. You'll notice there's not even the same number in each category. I'm going to go to stat, and I want to go to ANOVA. Now, remember, we're talking one-way ANOVA, and all my responses are in separate columns. Which columns am I interested in? Looks like 11, 12, and 13. So I'm going to plug those in, and it gives us confidence intervals. And the question becomes, does one of them look significantly different than any of the others, or at least one? In this case, they're a little different, but let's figure out if they're enough different. The answer here is p-value of, now the p-value here is a little weird. It is up near the top. 0.511, that is way bigger than 0.05, so we fail to reject that all 3 of the means are equal, meaning in essence all 3 of those stores are performing equally within reason. So that is ANOVA. So you have chi-squared, goodness of fit for equal frequencies or expected frequencies. You have two-way test for independence, whether the rows are related to the columns, and you have ANOVA, and ANOVA determines whether mu1 equals mu2 equals mu3. Okay, those are your basic tests. Those are how you run them in minitab. Make sure for your exam that you list HO, H1, the claim, what test you use, the p-value, and the claim that you're testing. Don't forget to take a look at your vocabulary as well.